Okay, example 1, compare the graphs of a function and its reciprocal. We're going to sketch the graphs of y equals f of x and its reciprocal function y equals 1 over f of x, and the function we're going to take a look at is where f of x equals 2x. And then we're going to take a look at how the functions are related. So we'll start by completing a table of values. Our function is y equals 2x, and our reciprocal of that is y equals 1 over 2x. So we'll start by plugging in x equals -4, so y equals 2 times -4, and we get -8. And then we get y equals 1 over 2 times -4, which will give us -1 over 8. And when x is -3, we get -6 and -1 over 6. And -2 gets plugged in, we get -4 and -1 over 4. So notice that we're getting reciprocal values here, right? For our original function we have -8, and our reciprocal function we have -1 over 8. Okay, and we would expect that because we're looking at the reciprocal of 2x. Alright, so let's continue. -1 gets plugged in, we get -2 and -1 over 2. Let's see what happens when we put in -1/2. So when I plug that in, I get 2 times -1 over 2, which gives me -1. And then when I plug in -1 into our reciprocal function, I get 1 over, oh, that should be -1/2, right? 2 times -1 over 2. Then I get 1 over -1, which equals -1. So look at that. We get a -1 and we get a -1. And we'll take a look at why that is later. Okay, let's plug in -1/4. We get -1 over 2 and -2. -1/6, we get 1 over 3 and -3. And then when we plug in 0, 2 times 0 is 0, and 1 over 2 times 0 is 1 over 0, which is undefined. Alright, so we're going to plug in the same x values but positive ones this time, so we will get the same y values but positive. So this will be 1 over 3 and 3, and 1 over 2 and 2, and 1 and 1, and 2 and 1 over 2, 4 and 1 over 4, 6 and 1 over 6, and 8 and 1 over 8. Alright, so let's take a look at the questions that we have here. What is the product of each pair of numbers in columns 1 and 2? Alright, well, we already know that they are reciprocals, and what happens when you multiply reciprocals together? Well, you're going to get 1. And that's because the product of reciprocals is 1. Okay, what happens to the values of 1 over f of x as the values of x increase? So let's take a look. We're going to start at -4 to -3, -2, -1. So the numbers are getting bigger and bigger, right? The closer we get to 0, the bigger those numbers get. And what is happening to our y values on our reciprocal function? We'll take a look. We've got a number very close to 0, but as x gets bigger, what's happening to our y value is that we're getting further and further away from 0. Okay? And the same is true for our x when we have positive values. Okay, we're getting bigger and bigger for x, and our y values are getting smaller and smaller. Okay, so what happens? They decrease in value. Okay, so what happens to the values of 1 over f of x as the values of x get closer to 0? Okay, well, let's take a look. Our x values get closer to 0, and if we take a look at the absolute value of these numbers, okay, they will become, so what we want to look at is the positive values. And notice that they are getting larger, okay? Their absolute value is getting bigger. And when these x values, our positive values, get closer and closer to 0, our y values are getting larger and larger. Okay, so we say that the absolute value of 1 over f of x gets bigger. I probably don't need to put that in because it's understood, right, by what we've written. Okay. All right, so why is the value of 1 over f of x undefined for x equals 0? Okay, well, I already said that. If I plug in 0 for x, then I get 1 over 0, and we can't divide by 0. Okay, so because we can't divide by 0. Okay, so let's take a look at how we graph this. Okay. Now, there's a few things on their table that I would like you to notice. The first one is here. Notice that your y value for both your regular function and your reciprocal function has the same number. Okay, they're both -1. And if you recall from previous lesson, when we have points on a graph that don't change, they are called invariant points. Okay, so they'll be the same for both graphs. And the other place that this happens is here. Okay, so we also have invariant points here. All right, and the other thing that I would like to draw your attention to is that when we plug in 0 for x in our reciprocal function, we get something that is undefined. And what happens to the graph here is that we get what's called a vertical asymptote. Okay, ASY MP TOTE. Okay, and I'm going to abbreviate that as VA. And it is always at the x-intercept of f of x. Okay, so it's an easy point to find. All right, so what do these look like on our graph? Okay, well, usually when we start graphing reciprocal functions, we start by graphing our original function, and our original function is y equals 2x. Okay, and our x-intercept is when y equals 0, so we plug in 0 for y, and we get that x is equal to 0. And we will find too that our y-intercept will give us the same thing, okay, because when x is 0, we get that y is 0. So our first point on our graph will be at 0, 0. And take a look, our slope is 2. Okay, so we're going to go up 2 and to the right 2, up to the right 2, and so on, and then down 2 and 1 to the left and 2 down, 1 to the left and 2 down, 1 to the left and 2 down, and we get this. Okay, so this is y equals 2x. Then what we do is we identify our x-intercept, and we know our x-intercept is right here at the origin, and this is where our vertical asymptote is going to go in. That's where our reciprocal function is undefined, and so we put in a dotted line through there. Okay, and notice it's at the place where x equals 0, so the equation to this line is x is equal to 0. Okay, and then another thing that we want to keep in mind are our invariant points, and notice that they happen when x is a half and y is 1. Okay, so where x is a half, y is 1 here, and the other time that it happens is when x is negative a half and we get y equals -1. So those are our invariant points. Okay, and let's take a look at, we'll do the positive part of our graph first. Okay, when x is 1 over 6, so a pretty small number, y is 3 for our reciprocal graph. So we go up here to 3. And when x is a quarter, y is 2. So when x is a quarter, y is 2. And then a half, we get 1. And then when x is 1, we get a half. And when x is 2, we get a quarter. And when x is 3, we get a 6. And take a look, our graph is going to look something like this. Okay. And now when we go to the negative part of our table, okay, we're going to start at -4 and -1/8. So -4 and -1/8, and then we're going to get -3 and -1/6, and -2 and -1/4, and -1 and -1/2, and here's our invariant point, and then we're going to be at, what was it again? We're going to be at -1/4 and -2. Okay, so -1/4 is around here, and -2, and then our next point will be around here. And look, we get something that looks the same, but in the third quadrant. Okay, now notice that the graph goes along our vertical asymptote here. It will never cross over because our vertical asymptote is undefined. Our graph will not ever meet that line. Okay? And notice too that the graph is gliding along the x-axis, okay, in both directions, going to the left and to the right. So we actually have another asymptote here. It's called the horizontal asymptote. It happens when y is equal to 0. And I will abbreviate HA.